All right, this is part 3 of section 3.3. In this question, we're asked to determine whether the function is increasing, decreasing, and or constant. Okay, so reading from left to right, and if we're talking about increasing, decreasing, or constant, we're talking about the x values here. Okay, so increasing, I see right here. This is increasing to this point, and increasing from here to about this point. Okay, so for this arrow, we know that this arrow right here, we know that it is extending out to negative infinity because it's on this side of the x value, and this is negative infinity for x value. Over here is positive infinity for your x values. Okay, so it's going from negative infinity and it's stopping at 1. So we'll say increasing starts at negative infinity and it goes to positive 1. Okay. And then also, notice this little line right here. Notice you got a dotted line and then both your graphs are getting really, really, really close to that dotted line. That dotted line is called an asymptote. So your graph will get really, really, really close to that point, but it will never touch that point. It will never cross that point. Okay, so looks like at this point right here, remember we're talking about the x values. So even though we've got this arrow pointing downward, don't say, okay, well that's negative infinity because that'd be talking about the y value. This would be negative infinity for y. This would be positive infinity for y. We're talking about the x value. So we're saying it starts about 3. So we're going to say that this is union or also starts at 3, and then it goes up to, looks like 4. So comma 4. Okay. So it's between these 2 points right here that it's increasing, and it's between these 2 points and then out to negative infinity that it's increasing. Okay, now let's look at decreasing. Okay, so it looks like it is decreasing from here to here and here to here. Okay, so it looks like it starts at 1. And remember, we're talking about x values. It goes up to about this 3. Okay, so from 1 to 3. And then also, or union with, looks like it starts at 4 and it goes out to the positive infinity for x values. So from 4 to positive infinity for x. Okay, I don't see a horizontal line anywhere within this graph, so we don't have a constant interval within this graph. Okay, let's look at this one. Same thing, determine where it's increasing, decreasing, or constant. So looks like it is increasing from here to here and from here to here. So I'm just going to write I for increasing. Okay, remember this is x values. We've got an arrow here. This is on the negative side of x, so it starts from negative infinity. It goes up to, looks like that's halfway between negative 3 and negative 2. So we'll say negative 2.5. Okay, and then also, or union with, looks like it starts at 1. And then this arrow here means it keeps on going, and notice it's over here on the positive x side, so it goes to positive infinity. Okay, decreasing, the only decreasing part I see is, let's move all of this from about here to here. So right there, that's the decreasing part right there. Okay, so it looks like it starts from that negative 2.5 and goes to the 1. So negative 2.5 up to 1. And I don't have any horizontal lines, so we don't have another, so again, we don't have a constant function, and that's it. Okay, same thing, increasing, decreasing, and constant. Where are those? And we'll go ahead and find increasing. So it looks like increasing is right here. Okay, so let me highlight that. Between these two, remember we're talking about x values, so that starts at, looks like negative 4. And it goes to, looks like 2. That's the only increasing that I see. Okay, we'll go to decreasing. Decreasing is, looks like right here. Okay, so let me highlight that. Okay, so notice how this goes off the graph. So it just keeps on going. So it goes, and we're on the negative side for x over here, negative side of x. So negative infinity to the negative 4. And that'd be our decreasing. And then I do have a horizontal line right here. Okay, so there's my constant function. Okay, so I have a constant function here. And that starts at negative, or sorry, 2. And it goes off the graph again, so, and we're on the positive side for x values, so it goes to infinity. Okay, this one we're going to find the local extrema for the graph. Okay, so this is an increasing graph, and notice that it's increasing right here. It's increasing, increasing, and then it changed to decreasing right here. So we went from increasing to decreasing, which means that I'm going to have a local maximum. Okay, so it looks like the local maximum will be about, let me get rid of this, about right here. That seems where it changes from increasing to decreasing. Okay, so for my local extrema, I have a local maximum. So I'm going to say local maximum of, remember, it's at a y value. So the y value is 5, and it occurs at x is equal to 4. So I have a local maximum, and let me put max right here. Local maximum of y equals 5, and that occurs at x equals 4. Now, a lot of students will get tripped up and say, okay, they have a point right here, that's got to be the local max, or that's got to be the local min. No, remember the local max is the highest point for the entire graph in that area. A local min would be the lowest point for that graph in that area, okay? So don't depend on where you have points like this, where you have a defined point with a circle there. That doesn't necessarily mean much. Okay, so let's look at this one right here. Determine any local extrema for the function graph below. Well, notice right here, I'm going from decreasing, 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 now I'm increasing, increasing, now I'm decreasing. Okay, so for the decreasing, so we're decreasing here, we're increasing here, and we'll draw little lines here, and we're decreasing again. If we're going from decreasing to increasing, I have a local minimum. So at this point, I have a local minimum. If we're going from increasing to decreasing, that means I have a local maximum. Okay, so if I've got a local maximum of y is equal to, okay, so let me get rid of that. Looks like it's right here, this point right here. So our y value is 2, and it occurs at x is equal to 1. And then I have a local minimum of y is equal to something. Looks like that occurs about here. That looks like -2. And that occurs at x is equal to, looks like, -1. Okay, and then let's talk about not a local max or min, but an absolute maximum and an absolute minimum. There's a difference between locating the highest and the lowest points on a graph in a region around an open interval or locally, and locating the highest and the lowest points on the graph for the entire domain. Okay, so we're not zooming in on one point or one area saying, okay, within that area, that's what we're doing here. We're zooming into this area here and this area here and saying, okay, within that area, we've got a local max and local min. But when we're talking about an absolute maximum and absolute minimum, we're talking about the absolute highest point or the absolute lowest point for the entire graph on the domain that we're given. Okay, the y-coordinates of the output at the highest and lowest points are called the absolute maximum and absolute minimum, respectively. Okay, so let's jump into this question here. Find the absolute maximum and minimum for the graph below. Give your answer as an ordered pair. Okay, so let's look for the absolute maximum. So absolute maximum. All right, so I need the highest point. Now, don't depend on these right here because that's not the highest point. Notice I can keep going up with my graph, and I have a point here and a point here that are higher than that point right there. And actually, those are the absolute maximum. That's the highest that that graph goes. So I need an order pair for that. So that one is -2, comma, 16. And we have, let's see, 2, comma, 16. Okay, and it said write it as an order pair. Now I need an absolute minimum. And for this one, get rid of all the markings. This right here is the lowest point, the absolute lowest point. There's no graph beyond that point right there. So that would be the lowest point. So that's our absolute minimum there. And we need to write that as an ordered pair. Now, this one's a little bit tricky. The graphs on the homework will not be this tricky. Looks like this is, for x value, it's 3. For the y value, I'm going to guess that's 11, -11. Because halfway between those two would be 10, so that'd be about here. So that we'll say that's about a -11. But that's the absolute lowest point on that graph. Okay, let's keep going. Find the absolute max and min for the graph below. Give you answer as an ordered pair. Now don't look at this one and say, okay, the highest point with what I see on this graph is about right there. So the order pair would be 5, 7, because that's not the case. Look at this over here. We've got an arrow that keeps going up, okay? So it will go past that point right there and keep going up forever, okay? So I don't necessarily have an absolute maximum because my graph will keep going up and up and up and up and up. So that means my numbers will keep increasing forever. And same thing over here. Don't say, okay, the lowest point is right here. So the order pair is 3, 1. Because look at this right here. You got an arrow. It'll keep going down and down and down forever. So for this one, the numbers will keep getting increasingly negative. So for this one, there is no absolute max and no absolute min.